Across 3 continents, cameras have captured unprecedented images of 3I Atlas from Spain to Thailand to Norway. Astronomers are witnessing a visitor from another star system behaving in ways that defy expectations. Each new image ratchets up the tension, showing the object under different skies, but also hinting at something hidden within. As it gets closer, a sense of unease pervades 3I Atlas isn't just passing by, and its secrets may be more disturbing than anyone imagined. The 3I Atlas update shocked the astronomy community. No one expected that on the same night, 3 countries halfway around the world, Spain, Thailand, and Norway, would simultaneously send back new images of the interstellar object. The skies and weather conditions in the 3 regions were completely different, yet all cameras recorded the same strange movement, as if 3I Atlas had deliberately appeared at that exact moment. What's more puzzling is that there's no sign of fragmentation, structural degradation, or any of the other telltale signs of disintegration that are common in objects that come from deep space. Instead, the new images reveal an internal transformation, a type of internal activity that has never been seen before. Some researchers even question whether we are witnessing a mysterious self-regulating mechanism or a purposeful signal from an object that doesn't belong in our star system. Whatever the solution, this is clearly the beginning of a mystery that astronomers are completely unprepared for. A story that could change humanity's current understanding of extraterrestrial beings and what is silently watching us from the depths of space. To understand why the new images are so shocking, we need to go back to where it all began. On July 1, 2025, during a routine scan, the Atlas Survey telescope in Rio Hurtado, Chile, unexpectedly picked up a strange signal, an early warning system that monitors fast-moving objects that could potentially approach Earth. Atlas immediately noticed that the object was traveling at speeds far beyond what is typically seen in space. The discovery was documented in the report with the working name A11PL3Z, a name that inadvertently opened the door to one of the year's biggest mysteries. Just days later, researchers trawling through the data stumbled upon older images from the Zwicky Transient facility, an observational system known for its ability to detect transient phenomena in the cosmos. It turned out the object had been seen since mid-June, but had been overlooked because it was moving too fast and out of the target area at the time. These pre-detection images immediately became key, helping astronomers reconstruct the object's path, calculate a more precise orbit, and try to decipher what was approaching our solar system. The fact that a mysterious interstellar object has appeared in past data, almost hidden until it actually appeared, has many experts wondering, is this just a coincidence of celestial mechanics? Or is there another layer of mystery that humans have not yet been able to penetrate? Further analysis revealed the first shock in the mystery of the object. Its orbit was neither elliptical nor parabolic, as is common with solar system objects, but a hyperbolic one, the kind that only occurs when an object has completely escaped the sun's gravitational pull. This meant it was definitely not a resident of our planetary system. It was just passing through, and once it left, it would never return. With clear evidence of its extrastellar origins, the object was officially named 3I Atlas, with 3I marking the 3rd interstellar visitor ever recorded. I standing for interstellar, and Atlas a nod to the telescope that discovered it. From the moment its name was announced, 3I Atlas immediately became one of the rarest objects humanity had ever seen. Only 2 other interstellar objects had passed through the solar system before, making each appearance a brief opportunity for us to glimpse the overwhelming vastness of the universe. Scientists immediately focused on analyzing its speed, brightness, and strange shape. Data collected in the first few weeks showed an unusual stability, almost too perfect for an object thrown into deep space without any stabilizing force. But that silence was like a shell that hid the anomalies that were slowly accumulating inside. And then, as if the universe had sent a warning to the next mysterious chapter, the first strange signs appeared in the silent night sky of Spain, where a camera recorded something that science seemed unprepared to face. In Extremadura, Spain, the camera was set to long exposure, a technique that causes the background stars to stretch into streaks of light due to the Earth's rotation. Yet, amid the streaks of light, 3I Atlas appeared in near perfect sharpness, despite hurtling through space at speeds that would deform any natural celestial body. Its central structure remained incredibly intact. No cracks, no distortions of light at the edges, not a single stray speck of dust, a level of cleanliness that almost defies all current understanding of interstellar objects. This unusual detail has scientists baffled. Objects with similar velocities typically exhibit signs of stress, such as altered light reflections, flaking surfaces, or at least a faint dusty streak. But in this frame, all of these familiar phenomena are absent. Instead, the core of 3I Atlas appears even more solid and robust than previously observed, as if it is undergoing some mysterious transformation that science has yet to describe. This is no longer an isolated anomaly in the photo. It is the first reminder that 3I Atlas may not obey the familiar physical laws that humanity has long considered immutable in the universe. The most striking of the series of images from Spain is the asymmetrical halo that appears near 3I Atlas's leading axis. This phenomenon has been observed faintly before, but never so clearly as to seem almost intentional as in this long exposure image from Extremadura. The halo does not flicker, nor is it stretched by motion, but is strangely stationary, suggesting that it may be a form of steady, continuous energy flow, unlike the random release of matter seen in active comets or asteroids. The biggest shock, however, was the absolute stability of the object's core. Under long exposures, all natural celestial bodies exhibit subtle fluctuations in brightness or small distortions due to background noise and motion. Not so with the 3I Atlas core. Its brightness was uniform, without fading or cracking, despite imaging techniques that magnify the slightest fluctuations. This level of stability far exceeds any known physical standard, regardless of the object's size or composition, leading researchers to wonder what could maintain such a structure, and why did its light behave as if controlled by some unknown internal mechanism. More remarkably, this stability was recorded at distances of thousands of kilometers, where the signal would normally be weak or scattered. 3I Atlas not only challenges the fundamentals of astrophysics, but also raises the question that within its core there may be a process that human science has never witnessed. While the images from Spain were enough to shake the scientific community, the observations from Rayang, Thailand took the mystery of 3I Atlas to a whole new level. The skies over Rayang that night were not conducive to any serious astronomical observations. Thin clouds constantly drifted in front of the lens, and high humidity scattered light, making everything appear blurry and distorted. Under such conditions, Capturing a clear image of a stationary target is difficult enough, but capturing details of a fast-moving object like 3I Atlas was next to impossible. But a strange paradox occurred. Despite all the atmospheric interference, the resulting images showed Atlas 3I with extraordinary clarity. Its brightness was almost identical to the data recorded in Spain. Its shape remained unchanged. Its light intensity did not fluctuate, and its structure remained incredibly sharp, as if the turbulent atmosphere had no influence on it at all. This fact led researchers to consider a more daring hypothesis. 3I Atlas seemed to operate on the basis of an internal mechanism, a strange kind of design that allowed it to maintain near-perfect stability, no matter how harsh the viewing environment. And it was then that a previously unspoken question began to arise. Were we observing a natural object, or were we witnessing a structure that could control its own shape and behavior as seen from Earth? Right at the center of the object, the light converges into a near-perfect circle, forming a concentrated halo around the darker core. This is not a random pattern of reflected light, but rather a precisely controlled structure, suggesting a degree of stability within the object that is unimaginable for a celestial body traveling at such a tremendous speed. Outside this circle, the expanding layers of light arrange themselves like overlapping shells. Each layer emits a softer light than the previous one, creating a multi-layered halo that extends outward. The layers are not blurred as atmospheric effects often do. Instead, they have clearly defined levels of brightness, giving the object an uncanny beauty, balanced and organized, as if created by conscious thought rather than by the randomness of nature. The detail that surprised scientists most was the gradient of brightness from the core outwards. When they compared the Rayang images with those from Spain, they found a striking match. The two observations, made thousands of kilometers apart and under completely different atmospheric conditions, produced almost identical patterns of light structure. Such consistency cannot be a coincidence. It requires a stable internal mechanism controlling the emission or release of energy within 3I Atlas. Nothing in the light pattern suggests chaos or randomness. The more astronomers studied it, the more they realized that this interstellar visitor operated according to principles that modern science had never predicted. It behaved as if it carried a string of secrets not meant for Earth, and each new image, each new data, only deepened the mysterious fog that surrounded it. As the world compared frames, Norway captured a photo that completely changed the conversation. The next important clue came from the quiet skies of Bordal. Norway, unlike the richly detailed long exposure images from Spain and the soft, wet frames from Thailand, the Norwegian observation lasted just an hour. But even with the shorter exposure time, the level of detail the astronomers captured far exceeded all expectations. The most striking feature is the tail that extends from 3I Atlas. Rather than being a simple streak of light, it has a distinct structure, as if revealing a new layer of information about how the object works. Along the tail, a faint curve appears, like a slight kink running through the stream of material. Remarkably, this kink is unaffected by atmospheric turbulence or camera shake. It remains the same throughout the observation. This can only mean one thing. The kink is coming from 3I Atlas itself. This curve is direct evidence that the object is rotating as it moves through space. This rotation can cause material to be pushed out unevenly, creating the slight twist seen in the tail. While rotation is not unusual for interstellar objects, the consistency and sharpness of the twist in this case is unusual. It looks almost too perfect, as if controlled rather than random. The Norwegian discovery is particularly significant because it adds a layer of movement to what had previously seemed a quiet, orderly picture. Images from Spain and Thailand show a stable structure and steady lighting, giving the impression of a solid, static object. But Norway's rotation suggests the opposite, a complex, quiet movement taking place beneath the placid surface. This steady rotation could explain why some core regions appear brighter, or why the layers of material are arranged like structural layers. The big question is, what forces cause this rotation, and how does it maintain such a stable balance in different viewing environments rather than being affected by external forces? The Atlas 3I appears to be self-regulating to maintain perfect balance. With its unique twist and distinctive tail shape, observations from Norway have opened up a whole new dimension to this mystery. 3I Atlas is not only stable, but also shows signs of a system operating in control. And while astronomers are trying to make sense of this new layer of information, observers in the United States are beginning to notice another clue coming from a faraway place. The next observational evidence came from the skies over Virginia, USA, where the camera was set to wide field mode to capture a much larger swath of sky than had been captured before. It was this extended view that revealed a completely new detail. 3I Atlas's tail was far longer than expected, spanning almost the entire frame in a thin, continuous band of light. Even as the object approached at extremely high speeds, this contrasts with the behavior of natural comets, which often leave behind fragmented and scattered light bands when viewed in wide field. Here, 3I Atlas' tail remained sharp and stable, showing no signs of tearing or distortion, as if some internal force was controlling its structure. This finding reinforces findings from Spain, Thailand, and Norway. 3I Atlas is not a passive wanderer in space. It is active, it is rotating, and that rotation is pushing material outward in a clear, orderly fashion. While the surrounding halo continues to expand with each observation, its core remains perfectly stable, unwavering even under long exposures and wide-angle observations. The center of 3I Atlas appears as a perfectly fixed point amid shifting layers of material. As research teams began compiling global data, the object's behavioral patterns became undeniable. 3I Atlas's structure, brightness, and motion all exhibited an uncanny consistency, forcing scientists to confront the big question: what was driving it? And what was its true nature? The mystery deepened when the James Webb Space Telescope turned its attention to 3I Atlas at a distance of 32 astronomical units from the Sun. JWST used infrared spectroscopy to analyze the object's composition and virtually recreate the environment in which it formed. The results revealed an unusually carbon dioxide-rich crust with a carbon dioxide to water ratio of 8:0, an extreme rarely seen in any comet in the solar system, along with water, that's CO, carbonyl sulfide, and ice dust particles. This suggests that 3I Atlas was born near the carbon dioxide ice boundary in the protoplanetary disk of its parent star, an environment very different from the formation region of familiar comets around the Sun. Further analysis has deepened the mystery. The object appears to contain large amounts of metal particles mixed with ice and carbon-rich material, a structure so rare that it has hardly ever been documented. This mix could explain the unusual halos that have been observed in many places around the world. Some scientists have even proposed the bold hypothesis that powerful chemical reactions, similar to Fischer-Tropsch synthesis, may be taking place as sunlight interacts with 3I Atlas's mixture of metal and carbon, creating organic molecules by a never-before-seen mechanism. All of these findings combine to paint 3I Atlas not just as an interstellar visitor, but as a chemical messenger from a distant world. Its carbon dioxide and metal-rich composition challenges current models of small body formation and suggests that the building blocks of life elsewhere in the universe may be profoundly different from what humanity knows. In this way, 3I Atlas is not just passing through the solar system, but also carrying with it the primordial memory of a distant star system, revealing to us in this brief moment a part of history that science has never touched. From July to September 2025, astronomers closely monitored 3I Atlas as it hurtled toward the inner solar system. Ground-based optical observations showed that the object's brightness, a direct measure of its activity, varied in a predictable but still surprising rhythm. As 3I Atlas moved from about 6 astronomical units AU to its closest approach to the Sun at 1.8 AU, the amount of dust it released increased exponentially, proportional to its heliocentric distance to the power of -1, 8. This suggests a steady and increasingly energetic response to the Sun's heat, as if the object were being activated as it moved deeper into the Sun's bright side. By the end of 2025, 3I Atlas had officially made history as the third interstellar object ever confirmed, after Oumuamua and 2I Borisov. But unlike its two predecessors, 3I Atlas displayed vigorous cometary activity with clear, stable, and richly detailed heads and tails. Its unusual chemical composition and strange light polarization behavior set it apart from familiar comets in the solar system. The 3I Atlas study has expanded our understanding of small extrasolar bodies. Scientists have realized that interstellar objects are not all simple chunks of ice, but can contain a variety of metals, carbonaceous materials, and complex structures. Data from Hubble, James Webb, and ground-based observatories help put its strange properties into a broader context, comparing it to common comets, trans-Neptunian objects, and carbonaceous asteroids. Although 3I Atlas has faded from view, its legacy remains. The object challenged long-held assumptions about comet formation and behavior, providing vivid evidence of the chemical and structural diversity found in other star systems to astronomers. 3I Atlas was more than just a passing stranger. It was a messenger from a distant world. And now, as it disappears into interstellar space, all eyes will be on what comes next from the stars. NASA has confirmed that the 3I Atlas is underway with high-resolution imaging. These could be the sharpest images ever taken of a moving interstellar object, providing the first direct look at the structure of the nucleus, head and tail in detail, never before achieved by any instrument. Scientists are eager to see whether the unusual features previously recorded from Spain, Thailand, Norway, and Virginia will maintain their high resolution, or whether the upcoming set of images will reveal additional structures never seen before. Around the world, observatories are entering a period of intense collaboration. Ground-based telescopes are tracking orbit, brightness, and changes over time, while space-based instruments are preparing to record exquisite details at multiple wavelengths. Each new data point to 3i atlases overall picture asymmetrical light, layered halos, twisted tails, and unusually stable structures suggest complex processes are taking place in its core. However, the limits of current resolution still leave many questions, and scientists hope that upcoming images will determine whether these features stem from rotation, chemical reactions, or an entirely new phenomenon. The anticipation stems not only from the breathtaking beauty of the images, but also from the desire to decipher the object's chemical composition. Previous infrared observations have revealed a carbon dioxide rich crust, the possibility of a metallic core, and unusual polarization signals. The high resolution images can directly link these chemical signatures to individual structures seen in optical images, connecting composition to the physical shape of an interstellar comet in real time for the first time. Meanwhile, 3i Atlas continues to exhibit unpredictable behavior. The gas cloud expands, delicate spirals extend along the tail, and the central core remains unsettlingly stable, as if an internal system is constantly in motion. Each new image released only deepens the mystery, suggesting that this object may be far more complex and dynamic than anyone had ever imagined for a comet. Now, as NASA's high-resolution images draw closer, the world is holding its breath. Atlas 3i is changing in ways no one could have predicted, and the next batch of images could change how we understand interstellar travelers. So, 3i Atlas global images reveal a rare and intriguing interstellar visitor that combines stability, motion, and chemical secrets in ways never seen before. Share your thoughts in the comments. What do you think this mysterious comet tells us about other star systems? And don't forget to subscribe to the channel to stay tuned.